Hello and welcome back to the channel. Today I'm going to introduce the Databricks Lakehouse Architecture and specifically the open source component, Delta Lake, and how it assists in the data quality fight. This is very much a short, high-level view of the basics for those new to Databricks, but it is key to understanding further videos to come where we will drill down further on each of the data quality features Delta Lake provides. So as always, let's lay out the objectives. As I mentioned, this is very much an introduction, so we can dive deeper into the Delta Lake later on. We will briefly touch on the problem the Databricks Lakehouse platform tries to solve. And from that, what is the Delta Lake exactly? Its purpose and where in the architecture it exists. Then I will cover the main Delta Lake file components and how it handles both structured and unstructured data. Very much an introduction. We will then answer why Databricks Delta Lake for data quality in a very broad way. As always, keeping our focus on the DQ space. Finally, I'll give a short summary and outline the next few videos coming up for the channel. So why the Databricks Lakehouse? What problem is it trying to solve? For years, organizations were forced to choose, use a data lake for cheap storage and scale, or a data warehouse for speed and quality. One or the other, depending on the requirements, the nature of the data, and your job role. And if they had both, this created its own set of problems. The data lake was great for storing raw, unstructured files like logs and images, but terrible for reliability. For example, if a write failed, you had corrupt files. On the other hand, data warehouses gave you the reliability um, with the power of SQL queries, but incredibly expensive if you wanted to bring in the lake data to make it useful. That data lake to data warehouse ETL process is where 80% of data engineers, their time is consumed. Data warehouses can be fragile on occasions, often break, depending on state of the data, etc. And it does result in two copies of the truth. We needed a better way, so introducing the Lakehouse architecture from Databricks with its unified solution to handling both unstructured and structured data under one roof, offering the best of both worlds, attempting to solve the complexity and reliability problem for all data, have that single source of truth, and for all data consumers, including business stakeholders, data scientists, engineers, as well as machine learning. So where does the Delta Lake fit in the overall Databricks architecture? Delta Lake serves as the critical storage layer that sits directly on top of your cloud object storage like AWS S3, ADLS, GCS. It is the technology that turns a standard data lake into a lakehouse by adding reliability, performance, and governance. The Delta Lake was built by the Databricks team. In turn, some of that engineering team were the original creators of Apache Spark. So they certainly know what they're doing. Um, and it's open source technology, so it's actually become a core component of most of the popular cloud platforms today, such as Azure, so Databricks and Fabric, uh, Google Cloud, there's BigQuery and Dataproc, and AWS, of course, Databricks again, Glue, EMR, and Redshift Spectrum. In a nutshell, the Delta Lake introduces a reliable transaction layer for the data lake. So again, Delta Lake is an open source storage layer that brings reliability to Delta Lakes. It does this by converting and maintaining data as Parquet files with its columnar performance benefits, but also adds a transaction log into a hidden folder, underscore delta underscore log. The conversion is different between supported structured and unstructured files. Structured file sources like JSON or CSV are converted straight to Parquet. But with most unstructured files like images and videos, the Delta Lake Parquet contains the reference path to raw storage, such as on AWS S3, as well as its associated metadata stored in that Parquet file. There is a secondary binary type option, which can convert the entire image to binary in a Parquet, but this is usually used on very small images, such as icons. Best practice is the metadata plus reference example. Uh, but the log is, that transaction log is really where the magic is. It tracks every transaction, allows us to know exactly where files belong to us, which files belong to a table and which are garbage. This design means you get the performance while keeping your data in an open format you fully control. In short, bringing order to the chaos of file-based storage. Data quality is not an afterthought for Delta Lake. It is enforced at that storage layer. Usually, data quality in the past is a script that you write to check for bad dates or nulls after the data has made it into downstream tables. Delta Lake somewhat changes that paradigm. It acts as a strict gatekeeper, and because of the transactional nature, it refuses to accept schema or constraint violations. In theory, Delta Lake turns data quality from a reactive cleanup process into a proactive architectural guarantee. So there is that mindset switch there. And we will dive into some of those individual features outlined there, such as time travel and ACID transactions in subsequent videos. But in short, no need to worry about partial rewrites, crashing data pipelines. In theory, Data Lake guarantees that if a job crashes, the data remains in a clear, valid state. A safety net that a raw Parquet or a CSV cannot offer by itself. So thanks for joining this introductory session into Databricks and the Delta Lake. In summary, we briefly touched on the purpose of the Databricks Lakehouse and also introduced the Delta Lake, a reliability layer for your lakehouse. We also got into the detail of the Delta Lake file components and how both structured and unstructured data are handled and stored. Then, most importantly, we tied the Delta Lake back to its embedded data quality philosophy as a proactive and reliable gatekeeper. But to understand how individual Delta Lake data quality features work under the hood, we need to go into more detail. So this is very much a introductory session. So next I'll be releasing a series of short focused videos to cover those individual features. Next video, for example, we'll tackle Delta Lake's ACID transactions and run some scripts to demonstrate that in action. Then we'll look at the concept of time travel, schema enforcement, and finally performance tuning. So look out for that one. So please, stay tuned for those deep dives. Thank you.